All right, so now we're going to get down to the nuts and bolts of it. We have y equal natural log of x, and we have y equals e to the x. These are two new functions who have moved in down the block, and you need to be able to see if you can, you need to be able to work with each of these with their derivatives and their antiderivatives. And so, here we go. First, we're going to find the derivative of the natural log of x. All right. What we mean is we need to find y prime, or find dy dx. Right. We need to find the derivative with respect to x of natural log of x. You do not need to be able to reproduce this, but when we get this final result, that's what you need to be able to work with. So I'm going to show you where this comes from. All right, so I want the derivative of natural log. Well, we know the derivative of natural log, we know that the natural log function, the definition is the definition of natural log is this area so far function. Natural log is the area so far function. Natural log is the area so far function. So the derivative of the natural log function is the derivative of the area so far function. But we know how to find the derivative of an area so far function. That's the second part of the fundamental theorem of calculus. The derivative of an area so far function, any area so far function, and this one in particular, the derivative of any area so far function with respect to x is, you take this upper limit of integration, substitute it into this function, and that's it. The second part of the fundamental theorem says the derivative of this kind of function, in this case, is simply, it's 1 over x. The derivative of natural log, and now eliminate the middleman. The derivative of natural log is 1 over x. The derivative of natural log is 1 over x. The derivative of natural log is 1 over x. And then we can use the chain rule with the chain rule, and this is the basic form. The derivative with respect to x of natural log of u is equal to some expression. The derivative with respect to x of natural log of u is argument goes to denominator, but then you need to multiply, because of the chain rule, multiply by the derivative of u. So, with the chain rule, this is the basic form for the derivative of natural log of u. I'm going to go through the derivative of the e to the x, and then we'll go through just example, so that you have this part of your mental furniture and you're able to work with it straightforwardly. Okay, our next piece is, again, you do not need to be able to reproduce this. This, at long last, is what you need to know. This is what you need to know, and this is what you need to be able to work with, and we'll do some examples of that in the next video. Now I want to talk about the derivative of y equals e to the x. So our task is we want to find dy dx. All right? We're going to find dy dx. And to do this, we're going to first to find this. Again, you do not need to be able to reproduce this. I'm just showing you where it comes from. Before we do the derivative, what we're going to do is simplify this expression a little bit, and that is we're going to take the natural log of the left-hand side, which is equal to the natural log of the right-hand side. Now, you'll recall from your glory days in basic algebra, properties of the natural log function is this: the natural log of a raised to the nth power. And with appropriate restrictions, these may be any real numbers. The natural log of a raised to the nth, do you recall this? You're allowed to move this exponent down to become a coefficient. This is equal to n times the natural log of a. This is one of the basic laws of properties of natural logs from your study in basic algebra. And so that is true here. We may apply this property, natural log of a raised to the n. We have the natural log of e raised to the x. We're going to apply that property here, which means take this exponent, move it down front. So now this is the same thing as x times the natural log of e. Now, the reason that helps is because it gets rid of this junk on the right-hand side. Because natural log of e, how much is the natural log of e? Well, that's the definition. The natural log of e is equal to 1. This is x times 1, which is just x. So what we have is that. Again, you do not need to be able to reproduce this. But now I got my ducks in a row. Now I'm going to find the derivative, and we use implicit differentiation from back before spring break. So the implicit differentiation says the derivative of natural log of y. Remember, anytime you take the derivative of a y, you need to multiply by dy dx. And we know the derivative of something. The derivative of something is 1 over u times this derivative. The derivative of natural log of something is 1 over the something times its derivative. So this implies that 1 over y times, what is the derivative of y? It is dy dx. That's got to equal the derivative of x. Well, the derivative of a linear term is just the coefficient. And now we're almost there. Remember, our task is to find dy dx, and we almost have it here. What we need to do is multiply both sides of this equation by y and clear out this fraction over here. So this implies, I'm going to gain some space over here. So this implies that dy dx is equal to 1 times y, which is simply y. Now, the final little denouement here is, what was y to begin with? Y was e to the x to begin with, so dy dx is e to the x. Now what does that mean? It means this. If y is e to the x, then the derivative is e to the x. The function e to the x is its own derivative. Y is e to the x, dy dx is e to the x. The function e to the x is its own derivative. If f of x is e to the x, it is its own derivative. It is its own second derivative. It is its own third derivative. E to the x is its own derivative. It is the only category of functions that has that property. There are some details to that, but e to the x is its own derivative. So, and we may use the chain rule for this. So if the question is, what is d by dx of e to the u, we can apply the chain rule. So this is not simply a single variable, it's an expression. This is e to the u times u prime. All right. So we have the derivative with respect to x of natural log is 1 over u times u prime. The derivative of e to the u is e to the u times u prime. And so we'll go through several little examples of that and just sort of beat that into you so we have that, those derivatives are in your comfort zone.